Welcome to the DIY Honda Garage channel. The DTC P0452 indicates that there is a low voltage issue detected in the fuel tank pressure (FTP) sensor circuit of the 2008 to 2012 Honda Accord. The FTP sensor plays a critical role in monitoring the pressure within the fuel tank, providing vital information to the engine control module (ECM) for managing fuel evaporation and emissions effectively. When the FTP sensor detects low pressure, it can affect the performance and emissions compliance of the vehicle. Being located near the fuel tank, this sensor is critical for optimizing fuel efficiency and ensuring compliance with emission standards. Understanding the various components and their locations is essential for effective troubleshooting. Now, let's explore the specifics of this error and navigate the troubleshooting process. The DTC P0452 specifically suggests a low voltage condition in the FTP sensor circuit. The fuel tank pressure sensor is responsible for measuring the pressure levels in the fuel tank, critical for maintaining controlled fuel evaporation and emissions. Typically situated on or near the fuel tank, its correct functioning is vital for proper engine performance. Inadequate pressure readings can mislead the engine control module into believing that there is an issue with the fuel system. This sensor's performance can directly influence fuel efficiency and emissions to remain within regulatory limits. Therefore, addressing this error is essential for maintaining the vehicle's operational efficiency and compliance. Several possible causes exist for the DTC P0452. A common issue is a malfunctioning FTP sensor itself. If the sensor is damaged or degraded, it may send misleading voltage signals. Additionally, wiring problems such as frayed wires or shorts can cause reading discrepancies, leading to inaccurate pressure readings. Poor electrical connections at the FTP sensor or the engine control module can also result in low voltage scenarios. Corrosion at the terminals could impair the sensor signal path, contributing to the error. Lastly, issues in the ECM may also influence sensor performance and readings. Ensuring all components are functioning well can aid in solving the underlying issue effectively. The symptoms of DTC P0452 include the illumination of the check engine light, indicating a fault within the system. Drivers may also notice poor engine performance. This can manifest as reduced acceleration, stalling, or other erratic behaviors as the engine management system struggles with incorrect pressure readings. Furthermore, increased emissions may occur as the engine attempts to manage fuel efficiency under faulty sensor conditions. In some cases, the vehicle could also experience difficulty starting, as the air-fuel mixture might be improperly managed due to inaccurate sensor input. Addressing the underlying cause is crucial, not just for system performance, but also for regulatory compliance. Start the troubleshooting process by turning the ignition switch to on. 2. This action powers the vehicle's electrical systems without starting the engine, allowing you to perform diagnostics. Use the Honda Diagnostic System, HDS, to clear the DTC. This resets the trouble code and allows you to evaluate if the issue persists. Keeping an accurate record of all freeze data and onboard snapshots before clearing codes is crucial. Freeze data provides a snapshot of conditions when the DTC was set, which may offer clues about the underlying issue. After clearing the code, proceed to the next step. Properly clearing the DTC is essential for effective troubleshooting. After clearing the DTC, turn the ignition switch to lock 0 to ensure the electrical system is off while performing the next task. It's time to remove the fuel fill cap. This action helps to relieve any pressure buildup in the fuel tank, enabling accurate readings from the FTP sensor during testing. By relieving pressure, you can ensure the sensor is read accurately, making the next diagnostic steps more effective. An improperly secured fuel cap can cause erroneous pressure readings, leading to a false sense of a malfunction. Thus, having the fuel cap off is a vital step before re-engaging the system. Now, turn the ignition switch back to on. Utilize the HDS to check the FTP sensor in the data list. You're looking for a pressure reading of about -7.3 kilopascals, which is equivalent to -2.16 inch Hague, or -55 millimeter inch Hague, or 0.3 volts or less. Such readings indicate that the FTP sensor is responding correctly to the pressure conditions within the fuel tank. If the readings fall within these parameters, proceed to step 10 as the sensor is likely functioning as intended. If the readings differ, step into the next troubleshooting phase to investigate the wiring or connections associated with the FTP sensor circuit. Monitoring these readings with precision is vital to accurately identify the issue. Next, after checking the FTP sensor readings, install the fuel fill cap. This step is essential to create a proper closed environment for the fuel system. It allows the fuel system components to work effectively under normal operational conditions. Following this, start the engine. This step ensures the system operates under actual driving conditions. Now proceed to the monitoring phase using the HDS, specifically watching the OBD, onboard diagnostics, status for the P0452 DTC in the menu. If the HDS indicates failed, you will proceed to step 10. If it indicates passed or an intermittent failure, check the connections for any loose terminals at the FTP sensor and the ECM, engine control module, as transient errors might lead to similar symptoms. Now, turn the ignition switch back to lock 0. This ensures the systems are deactivated, allowing safe maintenance procedures. Next, disconnect the FTP sensor connector, which is typically marked as a 3P connector. This action breaks the circuit, allowing you to evaluate the sensor's performance without interference from the rest of the system. Ensuring safe disconnection mitigates the risk of electrical shock or equipment damage. Upon disconnecting, you can further inspect the sensor and associated wiring for potential faults, which are essential in diagnosing the cause of the low voltage readings indicated by the DTC. Properly handling components ensures their longevity and accuracy in future assessments. After disconnecting the FTP sensor connector, turn the ignition switch back to on 2. Again, check the FTP sensor using the HDS. This step will reveal whether the sensor is still providing a low reading, indicative of its failure. Monitor the data list and look for indications of about -7.3 kilopascal or 0.3 volts or less. Similar readings to the previous checks confirm consistent sensor behavior under various states. If the readings remain the same, proceed to the next troubleshooting step to narrow down the possible causes. If the sensor operates outside expected parameters, it may require replacement. Consistent monitoring during these checks is paramount for effective troubleshooting. In this step, measure the voltage at the FTP sensor's 3P connector, specifically between terminal number 1 and body ground. Use a reliable multimeter to establish if you are receiving approximately 5 volts. This standard voltage is critical for ensuring the FTP sensor operates within its design specifications. If the reading meets or exceeds this threshold, proceed to the next troubleshooting step for more in-depth testing. If the reading is significantly lower than 5 volts, it may point toward issues either with the wiring or the power supply from the ECM. Having accurate voltage readings assists in determining the state of the electrical system, especially concerning standards for sensor operation. After completing the troubleshooting steps and any necessary repairs, it is crucial to conduct final checks. Ensure all components have been properly installed and seated securely, particularly the FTP sensor and all associated wiring connections. Confirm that there are no visible damages or disconnected terminals. It's also advisable to run a final diagnostic using the HDS to check if any DTCs have reappeared. If the P0452 code resurfaces, further investigation is warranted into the wiring harness and connector integrity. Completing these final steps effectively ensures that your vehicle is safe and functioning optimally after repairs. To prevent the reoccurrence of DTC P0452, implement a regular inspection routine for the FTP sensor. Regular monitoring can help catch early signs of wear or malfunction before they lead to more significant issues. Additionally, ensure that all wiring connections associated with the FTP sensor and ECM remain secure and free from corrosion. This can greatly enhance the reliability of sensor readings and overall performance. Maintaining the integrity of the fuel cap is equally essential, as a loose or damaged cap can induce pressure discrepancies that affect sensor readings. Proactive maintenance will help keep your Honda Accord running smoothly and efficiently. In conclusion, understanding the role of the fuel tank pressure sensor in the 2008 to 2012 Honda Accord is essential for troubleshooting DTC P0452. Recognizing the possible causes, such as a faulty sensor or poor electrical connections, can streamline your diagnostic efforts. Conducting thorough diagnostics at each warranted step will help efficiently resolve any emerging issues. Regular preventive maintenance can aid in avoiding future occurrences of this DTC. Ensuring clear communication with the vehicle's onboard diagnostics during troubleshooting is crucial for successfully managing repairs. By following these steps carefully, you can maintain optimal vehicle performance and compliance with emissions regulations. Please like and subscribe to the channel. See you next time.